Welcome to zebracode.io. This is a free high school coding curriculum, and now that we've learned about files and specifically working with CSV and text files, we're learning how to work with data, and we're going to continue along those lines. In lesson 13, we're going to focus on data structures. Now, we've already learned one data structure. We learned about the list, but we're also going to learn about a couple of other data structures, the dictionary and the tuple. So let's look at the list, the dictionary, and the tuple. The list is initialized by these square brackets. We've already seen that. The dictionary has these curly brackets, and the tuple has these parentheses, and we'll learn more about that in the syntax. So let's take a quick review at lists. Let's look at some basic code. We have my list is assign the value of an empty list using the square brackets, and we have some functions. We can look at the length of my list, and that will return the number of elements in the list. A list is nothing more than a collection of items. We have some common methods. We can append new items to the end of the list. We can pop items off the list, or we can insert items into a specific location. Those are some of the common methods available for lists. We can also access any element in the list by the position. For example, my list, square bracket 0, accesses the first element in the list. We can test for membership, whether it's in or not in the list. And some of the pros of a list are they're easy to use, we can sort them, and some of the cons is it takes a longer time to look up a specific item in a list. For example, if it's the last item in the list, we got to go through all of the items to finally find that last item in the list. Now, on the contrary, dictionaries provide us different functionality. Here's some sample code. My dictionary is assigned the value, and we use these curly brackets to define this as a dictionary, and dictionaries are key value pairs. So here I have some elements here. There's 4 elements, and we have the key is an ace, and the value is 11. The key is a king, the key is a queen, and the key is a jack. So we could have all these for all the cards, and we have the value, which is a numeric value, 11, 10, 10, or 10, and that's a key value pair. So everything has a key, and the key must be unique, and the values can be duplicates, but it represents the value. So similarly to a list, we can find the length of a dictionary, and if we want to assign a new item to a dictionary, we simply do my dictionary, put in a new key, and assign the value, and that adds a new item to a list, similarly to append. With dictionaries, we can also test for membership. We can look for in or not in those keywords, and that checks the keys if that key is currently in the dictionary. The pros of a dictionary is it has a very fast lookup time or constant lookup time, and the cons are it takes a little bit longer to build a dictionary, and you can't sort or there's no order associated with it, and you can't look up an item by its position. Finally, let's look at tuples. Tuples are denoted by these parentheses. So we have my tuples assigned the value, and here it's assigned to an empty tuple. And one of the functions are similar to with lists and dictionaries. We can find the length of the tuple, which will determine how many elements are within the tuple. Here's an example of assignment of a tuple. My tuple is equal to, and here we have 4 elements. It's a movie name, and it might be the revenue and the average rating and the producer. And these are set. So these can represent, for example, a record of all the things we want to store relative to this movie. You can access an element specifically by position, similarly to a list. So you can do my tuple in square brackets and have 0, and that's going to find the 0 position. So the pros are they're good for storing fields and columns for one record, and the cons are they're immutable. That is, you can't add a new item to the tuple, can't add a new element, unlike a list or a dictionary where you can. Let's look at a summary of these data types. First of all, we have a list, and here's how you would initialize it. Capital L is assigned the value and using the square brackets. And a list is mutable. That means you can add items to it or subtract or append or pop and insert. We learned about those. And it's also sortable. Those are the strengths of a list. A dictionary, on the other hand, is denoted by these curly brackets, and similarly, it's mutable, that you can add items or you can take items out. They're key value pairs instead of just based on a position within a collection, and they're very good lookup tables, and they're very good for finding any item in the dictionary at a constant rate that you can find, whether it's the first item or the last item. It takes the same amount of time to find any item. Finally, let's look at tuples. Tuples are denoted by these parentheses, and the first thing about tuples, they are immutable. That is, you can't add or subtract items from the tuple. So they are essentially act as containers. So they're good for storing records that have a set number of fields. And we're going to learn about mixing and matching these data structures. For example, we can have a list of tuples or a dictionary of lists. Let's look at some sample code. Here's a review of lists. We have an initialization. My nums is assigned the value of a list, and we can append 5 to that list. We can append 12 to that list, and now we can insert 4 in the 0 position. We can pop, which removes the last item, and then we can print my nums. Here's some basic dictionary code. We have states as assigned the value. We have as keys CA, OR, and WA, and those represent values of California, Oregon, and Washington. And now we're going to add a new key, FL, which represents Florida. We can pop CA, which removes from the dictionary CA and California. We can print all the states, and we can print the length of the states, which is how many elements or key value pairs we have within our dictionary. Here's some additional dictionary code. We have airports as assigned an empty dictionary, and we're going to add in some keys, SMF, which equals Sacramento International, and we have some other keys associated with different airports. Now we can iterate through the entire dictionary for X in airports, and we can print. X is going to represent the key value, and the dictionary value with square brackets of the key prints out the value of that dictionary. Let's look at some simple tuple code, and here we have 3 tuples, and sometimes they're pronounced tuples, so tuples and tuples, but we have tup1, tup2, and tup3, and each of these have 3 elements. It has a city name, Sacramento, Davis, and Roseville. Then we have, for example, the rent prices, which may have been 10 years ago, and the current rent prices. So we have basically 3 elements for each tuple, and now we can print based on position tuple 2, the 0 position, which would be Davis, and we can print tuple 2, second position, which is the highest rent in Davis, or the most current rent. Finally, let's introduce the topic of mixing and matching data structures. So here I start with import date time, and we'll introduce date times, which are a very simple way of managing dates. And we have an empty list called students, and we have tup1, and that's assigned the value of a name, and then we also have some type of date here, and it uses the datetime.date, and then we pass it the year, the month, and the day, and that creates a datetime object. So we append that now, tup, to our students list, and we create another tup, and then we create another tup. So we do this 3 times, and we append it to the students list each time. And at the very end, we have a list of tuples, and the tuples have 2 elements each. One is a name, and one is a date. And when we want to iterate through the students, we can print either the first element or the 0 element, whatever we want, or both elements. And we'll be doing more and more of this. This is a very common design pattern where we have tuples, which represent records, and we create a list of records, and we store those as tuples. And so we have we're mixing and matching. We can have tuples of dictionaries, and we can have lists of dictionaries and dictionaries of lists, and the list goes on and on. We can mix and match, and we'll do that more when we get into the data analysis section. So this is zebracode.io. This is lesson 13, and we're learning about data structures.